everyone. Welcome to SWAM online lecture series on the topic Database Management System. I am Muhammadullah Bukhari, working as a professor in the Department of Computer Science, Aligarh. I am pleased to have you join me today as we explore the fascinating realm of data, databases, and database management system. In the next few minutes, we will journey through data modeling using the entity relationship and ER diagram that form the backbone of modern information system, which is database management system. In the previous session, we have discussed data independence, types of data independence, data abstraction, significance of data independence, difference between data abstraction and data independence. In today's lecture, we discuss about database management system architecture and data independence. Now, let us access in today's lecture, we will discuss about entity relationship ER diagram and relationships. Now, let us access your knowledge and track your progress with a few thought-provoking questions. In the last lecture, we have discussed and giving you to some questions. The first question was, describe the significance of data independence. Data independence is a crucial in database management system as it ensures that changes to the structure or organization of data do not affect the applications using that data. There are two types of logical and physical. Logical data independence shield application programs from changes in the logical structure of database, allowing modification to the schema without impact the application's functionality. Physical data independence protect applications from changes in the physical storage structure of the database, enabling alteration to a storage mechanism without requiring alternation to application programs. This independence enhances flexibility, simplifies maintenance, and reduces the risk of data corruption or loss. The next question was, what do you mean by data abstraction, and explain it brief? The answer is, data abstraction refers to the process of hiding complex implementation details and presenting only the essential features of data to the user. In the context of database management system, data abstraction involves creating a conceptual model that represents the data independently of how it is stored or accessed. This abstraction simplifies the interaction between the user and database by providing a high-level interface that shields across user This abstraction simplifies the interaction between the user and the databases by providing a high-level interface that shields users from the complexities of the underlying data structures and operations. It enables user to focus on the relevant aspects of data without needing to understand the intricacies of its storage or manipulation. It enables user to focus on the relevant aspects of data without needing to understand the intricacies of its storage and manipulation. The third question was, what is the data independence in database management system? Data independence in database management system refers to the ability to modify the database schema or physical storage without affecting the application programs that access the data. It comprises two types: logical and physical data independence. Logical data independence shield application programs from changes in the logical schema, allowing alterations in the data organization without requiring modification to the existing queries or applications. Physical data independence isolates application from changes in the physical storage structure, enabling enhancement or optimizations in a storage mechanism without impacting the data access or application functionalities. Overall, data independence enhances flexibility, scalability, and maintenance in DBMS environment. The last question was, what is the role of user interface in the database management system? The user interface in a database management system serves as a primary means to user to interact with the database. It provides a platform for user to input queries, retrieve information, and manipulates data without needing to understand the underlying database structure or query language intricacies. The user interface presents data in a user friendly format, facilitating ease of use and understanding. It also enforces security measures, controlling access to database on user privilege. Essentially, the user interface acts as a bridge between user and database, enabling efficient communication and interaction while abstracting the complexities of data operation. So the agenda of the today lecture is, we will discuss what is the entity relationship model, why we use entity relationship diagram, symbols and components of ER diagram, types of attributes, what is relationship and its type. Let's discuss what is the entity relationship model. All right, let's kick off the entity relationship ER model. Imagine it is a blueprint of our digital world. It helps us design how different pieces of information related to each other. An entity relationship diagram describes the relationship of entities that need to be stored in a database. ER diagram is mainly a structure design for the database. It is a framework using a specialized symbols to define the relationship between entities. ER diagram is created based on three main components: entity, attributes, and relationships. The ER model provides a way to conceptualize and organize data in a manner that reflects the real world relationships and entities. It is particularly useful during the design phase of a database, when database designer need to understand, communicate, and visualize the structure of the data. The ER model uses various symbols and notation to visualize and represent these components. ER model ER model uses various symbols and notations to visually represent these components. Entities are typically represented by rectangles, attributes by ovals, and relationship by diamond shape. Lines connecting these symbols indicate the nature and cardinality of the relationships. The entity relationship model also introduced the concept of keys, which are attributes or combinations of attributes that uniquely identify each instance of any entity within an entity set. Keys are crucial for maintaining data integrity and ensuring that each entity is uniquely identified. Entities in ER model can further be categorized into strong entities and weak entities. A strong entity is one that can be uniquely identified by its attributes, while a weak entity depends on a related strong entity for identification. This distinction helps in understanding the hierarchical nature of entities within our database. Another key concept in the idea of cardinality, which defines the number of instances in one entity set related to the number of instances in other entity set through a relationship. Cardinality can be one to one to many to many, providing a way to express the nature of relationship in the model. ER model is an essential tool during the initial stages of database design. It facilitates communication between database designer, stakeholders, and end user by providing a visual representation of the data structure. This visual representation aids in identifying entities, attributes, relationships, or constraints, leading to a more comprehensive understanding of the data. The ER model is an essential tool during the initial stage of database design. It facilitates the communication between database designer, stakeholders, or end user by providing a visual representations of data structure. This visual representation aids in identifying entities, attributes, relationships, and constraints, leading to a more comprehensive understanding of the data. The entity relationship model is a foundational framework in database management system that offers a structured and visual representation of the relationships between entities in a database. It is an indispensable tool for database designers, enabling them to capture the intricacies of real world scenarios and providing a roadmap for implementation of efficient and well structured databases. Let's understand why we use ER diagram. Well, there are like treasure map for database. ER diagrams visually represents how data entities connect, making it easy for us to understand, design, and communicate complex relationships. ER diagram help us to conceptualize the database and help us know which field need to be embedded for a particular entity. ER diagram gives a better understanding of the information to be stored in database. ER diagram reduces complexity and save time, which allow you to build database quickly. It helps to describe elements using entity relationship modeling. Advantage of ER model: simple, effective, easy to understand, integrated, useful in decision making, and the last is easy conversion. Let us start one by one. Simple. It is a simple to draw an ER diagram when we know entities and relationship. Effective. It is an effective communication tool, easy to understand. The design of ER diagram is very logical and hence they are easy to design and understand. They show database capabilities. They show database capabilities like how tables, keys, and columns are used to find a solution to a given question. Integrated. The ER diagram model can be easily integrated with a relational model. Useful in decision making. Since some of the entities in the databases are analyzed by an ER diagram, so by drawing an ER diagram, we come to know. So by drawing an ER diagram, we come to know that what kind of attributes and relationship exist between them. Easy conversion. It can be easily converted to other type of model. Flexible. ER diagram model are flexible and can be modified easily to accommodate changes in the database design or structure. Minimizes data redundancy. ER diagram model help minimizes ER diagram models help minimize data redundancy by identifying and eliminating duplicate data entries. Scalability. ER model can be used to database for verifying size from a small to large. Visual representation. ER model provide a visual representation of the database structure, making it easier to stakeholders to understand and provide feedback. Documentation. ER diagram model provide useful documentation for future reference, making it easier to maintain and update database in the long run. Disadvantage of ER model. Loss of information. While drawing an ER model, some of the information can be hidden or lost. Limited relationship. ER model can be represented limited relationships as compared to other models, and it is not possible to indicate primary keys and foreign keys when they are expected. No representation for data manipulation. It is not possible to prevent, it is not possible to represent data manipulation. Commands like insert, delete, alter, update in ER diagram model. Next advantage is no industry and standard. Next is no industry standard. There is no industry standard for notation of an ER diagram. Data inconsistency. Due to improper normalization, some data inconsistency can be occurs. Data inconsistency. Due to improper normalization, some data inconsistency may occur. So while creating an ER diagram, at least it should be in third normal form. Missing cardinalities. Missing relationship cardinalities. So everything looks like one-to-one relationship, one-to-one relationship are actually quite rare. Difficult to modify. ER model can be difficult to modify once they are created. Any changes made to the model may require extensive work, which can be time consuming and expensive. Limited attributes representation. ER model may not be able to represent all the attributes required to a particular problem domain. This can lead to either the loss of importance of data or the creation of complex or unwidely model. This can lead to either the loss of important data or the creation of complex, unwidely model. Lack of support for business rules. ER model do not provide support for business rules, which can make it difficult to ensure data integrity and enforce constraints. Difficult to scale. AR models can be difficult to scale to accommodate large data set. As the amount of data in the database grows, the AR model may need to be modified to handle the increased complexity. So, we let us discuss about symbols ER diagram. Now let's decode the secret language of ER diagram. Symbols like rectangle for entities, diamonds for relationship, and the line connecting them form a visual code that speaks volumes about data connections. Example of ER diagram. From the above example, we can see the relationships work for is between entities, employee, and department. Employee ID, employee name, salary are the attributes of employee entity. Department ID, department name are the attributes of the department entity. Components of ER diagram. Components of ER diagram are entity, attributes, and relationships. An ER diagram in databases uses entities like categories, attributes, details, and the relationships, connections. It is a visual tool for simplify how information fits together, making database design and implement easier. Entity. An entity may be an object with a physical existence, a particular person, car, house, or employee, and so on. It may be an object with a conceptual existence, a company, a job, or university courses. An entity type has a key attributes that uniquely identifies each entity in the entity set, but some entity types exist for which key attributes cannot be defined. These are called weak entity types. A strong entity is a type of entity that has a key attribute. A strong entity does not depend on the other entity in the schema. It has primary key that helps in identifying it uniquely, and it is represented by a rectangle. These are called strong entity type. The other is attributes. Every entity has its unique features called attributes. So before we know the types, we must know the what is attributes. The attributes is used to describe the properties of entities. Eclipse is used to represent an attributes to represent the main characteristics of an entity. It represents a primary key. The key attributes is represented by an the key attributes is represented by oval with a text understanding. An attributes that composed of many other attributes is known as composite attributes. The composite attributes is represented by ellipse, and those ellipses are connected with an ellipse. And attributes can have more than one value. These attributes are known as multi-valued attributes. The double oval is used to represent multi-valued attributes. And attributes that can be derived from other attributes is known as derived attributes. It can be represented by an dash ellipse. The third one is relationship. A relationship is used to describe the relationship between entities. Diamond and rhombus is used to represent the relationship. In the example below, both the student and the course are entities, and the study is the relationship between them. In database management system, an entity relationship diagram visually represent the relationships between entities in a table. In database management system, entity relationship diagram visually represents the relationship between entities in a database. These relationships depict how data entities related to each other, showing connections like one to one to many to many, or many to one. Using symbols and lines, ER diagram illustrate the structure and dependencies within the database model. Relationship define how entities interact, influencing data integrity, querying, and database design. By clarifying the connection between entities, ER diagram aid in database development, communication, and understanding of the data organization, ensuring the efficient storage and retrieval of information in DBMS environment. What is the relationship and its types? What is the relationship and its types? One-to-one relationship. Only one instance of any When only one instance of any entity is associated with the relationship. For example, you have two types of things in your database, like person and passport. And one-to-one relationship means each person has exactly one passport, and each passport belongs to exactly one person. It's like a direct link between them. So, if you have a person, you know they have only one passport, and if you have a passport, you know it only belongs to one person. This kind of relationship helps keep thinking organized and avoid confusion. It's like each person has their own unique passport, and each passport is connected to one specific person. One to many relationship. when only one instance of any entity on the left and more than one instances of entity on the right association with the relationship. For example, a customer can place many order, but an order cannot be placed by many customer. In an entity relationship diagram, one-to-many relationship signifies in entity relationship diagram, one-to-many relationship signifies a connection where one instance of any entity type is associated with multiple instances of another entity type, but each instance of a second entity type is associated with only one instance of the first entity type. This relationship illustrated by a line connecting the two entities with the crow's foot symbol on the many sides. For example, a customer may have many orders, but each order belongs to only one customer. One-to-one relationship are common in database modeling and helps organize data hierarchically, reflecting real-world scenarios such as parent-child relationship is the example of one-to-many relationship. The next relationship is many-to-one relationship. When more than one instance of entity on the left and only one instance of the entity on the right associates with the relationship. For example, a student have to opt for a single course, but one course can be taken by many students. In ER diagram, many to one relationship donates in entity relationship diagram, many to one relationship indicate a connections where multiple instances of one entity type are associated with the single instance of another entity types. This relationship is depicted by a line connecting the entities, usually with a crow's foot symbols indicated the many sides. For instance, in a student teacher, we take example of a student teacher. A student teacher relationship, many students can have the same teachers. However, each student is connected to only one teacher. Many to one relationships are prevented in database design, represent scenarios where entity one side belongs to a single entity on the other side, adding in the idea, adding in the data organization and clarity. Many to many relationship. When when more than one instance of entity on any one more than one instance of the entity on the left and more than one instance of entity on the right associates with the relationship. For example, you can assign an employee to many projects and projects can have many employees. In an ER diagram, a many-to-many relationship signify a connection with multiple instances of one two entities are associated with multiple instances of another entities. This relationship represented by a line connecting two entities, often accompanied by a crow. This relationship is presented by a line connecting the entities, often accompanied by a cross-foot symbols on both sides. For example, in a student to course relationship, for example, in a student to course relationship, many students can enroll in multiple courses and each course can have multiple students. Many to many relationships are common in complex data models and are typically implemented using by intermediately and are typically implemented using an intermediary tables to resolve the many-to-many association, enabling efficient storage and retrieval of related data across entities. In today's lecture, we discuss about database schema and data dictionaries. Now, let's access your knowledge and track your progress with a few thoughtful, provoking questions. Your answer will not only info Your answer will not only reinforce your understanding but also serve as a valuable gauge of your grasp on the crucial topics discussed today. The today's question to test your knowledge are: what is the primary purpose of ER diagram model in database? What do you understand by ER diagram and explain in detail? Describe symbols and components of ER diagram. What is relationship and its type? Next question is describe the difference between weak and strong entities. The last question is what is the cardinality of a relationship in ER diagram model? In our exploration today, we have navigated the intricate world of data modeling using by entity relationship, peaked with ER diagram. Join us in our next lecture as we explore further advancement in ER diagram and their practical applications. Here, I would like to inform you that all of you are requested to revise the concept of today's lecture so you will be able to understand the detailed example in next lecture. Thank you for your participation and see you in the next class.